Hi guys, a very warm welcome, and in this video we are going to talk about some more components of the virtual private cloud. So first of all, I'm going to discuss about the access control list or the ACLs. The ACLs are also called as NACLs, the network access control list, and they are primarily required to provide additional security to the VPC. It adds an additional security layer that controls the inbound and outbound traffic rule at a subnet level in your VPC. And it's an optional thing. It is not mandatory that you need to create an ACL in your virtual private cloud. Generally, when we work in the default VPC, there are default ACLs also present, provided by the AWS. And they allow by default the inbound as well as the outbound traffic. So that's the reason we haven't noticed it yet in the default VPC. Whereas when you create a custom ACL inside your VPC, then you need to provide the type of an access in the form of allow and deny rules. So that's one of the benefits of the ACL is that it gives you an opportunity, it gives you the privilege that you can allow certain traffic also coming from the internet or going towards the internet or any other network, as well as you can deny the traffic as well. Let's take an example. Let's say if you know that you want to blacklist or block certain IP addresses or the ranges reaching towards your application, you can do that from the ACL. You can deny those IP addresses. All right. So that's what the benefit of an ACL is, that it can specify, it can allow as well as deny the rules. The ACLs are always implemented from a subnet level. So a subnet can be attached with only one ACL, and whatever the rules that are defined in the ACL, that will be followed by the subnet. Rules are evaluated starting from the lowest rule number. So let's say I create two rules in the ACL, rule number 1 and the rule number 2. So rule number 1 being the lowest one would be given the highest priority. So ACL is going to check what is there in the rule number 1 and then it will move to the rule number 2 likewise. Now you already know about the security groups, and we have seen the security groups created in the EC2 instances. Now what is the difference between an NACL and the security group? Both gives the security options. Both protects the resources inside the VPC. But NACLs are stateless, whereas security groups are the stateful. Stateless means that they do not capture the traffic information, or they do not store the traffic information. NACLs are defined on a per subnet basis. Security groups are defined on the instances created inside the subnet. Security groups are mostly a firewall rules. NACLs can allow and deny the traffic. Security group can specify only allow rule. So when you open up the ports in the security group, you can allow the traffic, but there is no option to deny it. And then a subnet can be assigned only one NACL. An instance can be assigned with multiple security groups based on the AWS recommendations and the capacity. So that is what the difference between the NACL and the security groups are. A demo to create a non-default VPC and attach it to an EC2 instance we have already done in the previous video. Now we are going to understand about the network address translation or the NAT. Some people call it as NATing also. Now what is the NAT or the network address translation means, or why it is required in the VPC. So NAT devices enable instances in the private subnet to access the internet or other AWS resources, but they prevent the internet from initiating connection to the instances. When we have internet gateway to access the internet, why do we need NAT? NAT acts as NAT device also acts as a proxy server. Generally what happens, guys, is that internet gateway, when you attach it to the VPC, so let's say you know what exactly the internet gateway is. We have seen that in the previous demo also. So when you attach an internet gateway to the VPC, it works in a bidirectional mode. It accepts the inbound traffic also, it sends the outbound traffic towards the internet or any other network. So it's a two-way communication. When you expose your subnets to the internet gateway, any resource that you create inside the subnet would also have an access of the internet because they are directly connected to the internet gateway. So this way, you cannot restrict or isolate your resources on the internet. Now, for example, let's say I create a database in a private subnet inside the VPC, and the requirement is that that database instance should have the internet access. So within the database instance, we should be able to access the internet, but without risking the security of that database instance. How we can achieve that? If I directly connect the database instance with the internet gateway using the route table, then the database is completely on a public network. There is no restriction. So NAT devices play an important role in this particular concept where they act as a proxy server. And I'm going to demonstrate it also, how does the NATing happens in the form of a diagram, and then we are going to implement it in the lab environment as well. So when we talk about the NAT devices, generally there are two types of NAT devices. One is the NAT gateway and the other one is the NAT instance. NAT gateway is the fully managed device by the AWS. So AWS is going to manage the redundancy of the NAT gateways. It is going to provide the bandwidth also likewise. And hence the NAT gateway creation is chargeable. So when you create a VPC and inside the VPC you create a NAT gateway, it's a chargeable service. Alternate to it, you can also create a NAT instance which just works like an EC2 instance, but in the NAT instance, everything you need to manage. The administrator needs to manage it. NAT instance is definitely a cheaper option, depends on what type of an instance that you are going to select. Now we are going to understand the concept related to NAT gateway from a diagram perspective. So guys, let's try to understand the concept of NAT gateway inside the VPC, and then we are going to implement that functionality in the lab environment. So by now we have worked on the VPC. So let's say this is the virtual private cloud and I assign a CIDR block to it. Let's say I assign 10.1.0.0/16, and then I create two subnets for the instances and name it as public subnet and the private subnet. And obviously in the public subnet I have a website or a web application, and on the private subnet I have the database instance created. I'll name it as DB. And then we have a main route table by default provided by the AWS VPC, And here what we did, we added up a rule 0.0.0/0 and target was internet gateway. And where is the internet gateway? It is attached to the VPC. Let's say this is an internet gateway. Alright. And then we associated the public subnet with the main route table, so that whatever the rules that are applied or added on the main route table, that will be followed by the public subnet. Obviously there are default ACLs which allows the rule, so that's the reason it has not been added. And the target is internet gateway, so any traffic that comes from the internet would go towards the public subnet and vice versa. So let's say this is the internet connection, which is pointed towards the internet gateway. So internet gateway allows the inbound traffic as well as outbound traffic from the web server towards the instance. Now what you observed, in the private subnet the database instance is isolated. It does not have any exposure on the public network on the internet. Because of the security reasons, we have not provided any route towards the private subnet. Now what the requirement is? The requirement is that from the database instance, from here within, the internet access should be provided because of let's say admin wants to download some softwares or some packages for the databases, so internet access is required. But parallelly, we do not want to risk the security of this database instance. Why? Because this has to be very secure because it has some critical data inside it. So how we can achieve that? And this can be done with the help of a NAT gateway or the NAT device, which acts as a proxy server. So I'll just erase the web instance. Just give me a minute. And here what I'll do, instead of a web instance, or I'll just put a web instance here. So to achieve this particular functionality, what we need to do is we need to create a NAT gateway. And the NAT gateway is always created. You can make a point of it. You can note down it. The NAT gateway is always created in a subnet which is associated with the internet gateway. That means that subnet who has the internet access, there only the NAT gateway has to be created. So I'll be creating a NAT gateway in the public subnet. Okay, so I'll just name it as NAT gateway, or you can put it at NAT GW. This is fine. Just a minute. Or let me do it better. Subnet. And this is going to be a NAT device. Alright. Now when you create a NAT gateway, this NAT gateway gets an elastic IP, elastic public IP, which is mandatory. So an elastic IP has to be provided to this NAT gateway. Why? Because the NAT gateway should have the public IP so that it can be available on the internet. It is acting as a proxy server only. Now the next thing is, the purpose is we need to provide the database instance the access of the internet, but we want to secure it also. So what we'll do, we'll create another route table, and that is going to be the custom route table. We can add as many route tables we want in the VPC. So I'll just name it as a custom route table or custom RT. And I'm going to associate the private subnet with the custom route table. Not with the main route table, but only with the custom route table. And then in the custom route table, I'm going to add a rule which is again going to be a default rule, 0.0.0. So let's say I add the same rule, the default rule 0.0.0/0 to allow all the traffic. But this time I'll point it towards the NAT device or the NAT gateway rather than the internet gateway. Now what would happen in this case is, let's say when you log in into the database instance, and obviously you would log in on the database instance from one of the dummy instance in the public subnet. So what you need to do is, and I'll show you how, you would first log in into the web instance from the internet, and from the web instance you will jump into the database instance using the private internal IP. Why? Because the public subnet and the private subnet has the internal connectivity. And once you log in into the database instance, if you have all this configurations done, all this networking done, then from the database instance you should be able to access the internet without risking the security of your database instance. Why? Because when you log in into the database instance and search for any website or try to browse any content on the internet, that request would actually forward it towards the NAT gateway with the help of this custom route table. And the NAT gateway has a public elastic IP. So NAT gateway would forward that request further to the internet gateway and then to the internet. So any server on the internet would think or would find that the request actually came from an elastic IP that belongs to a NAT device. But we know that from the database instance itself the request was raised. But since the database is using the NAT gateway as a proxy, hence the database is protected. The NAT gateway is visible on the internet. So nobody is going to know the existence of the database instance. Still you will be able to access the internet. And that is what the NAT gateways are used. So we are going to do this demo in the next video. And we'll see how we can access the internet from the database instance with the help of the NAT gateway. So the next concept that we are going to discuss is the VPC pairing, which is quite an interesting topic or the component of a VPC. The VPC pairing helps you to connect your VPC or one of your VPC to another VPC. So let's say if you are having multiple VPCs, you can connect them. You can even pair the VPCs created in different AWS account as well. So here you can see in the diagram, VPC A paired with VPC B, VPC A paired with VPC C. All of the VPCs are having different IP CIDR block. The benefit of the pairing is that the resources that are created inside the VPCs, they can intercommunicate. So I can have a VPC pairing in the same region. I can have a VPC pairing in a different regions also. I can even have a VPC pairing in different AWS accounts. And I can have a VPC pairing in different AWS account, different regions also. These are the 4 options. So here you can see, this is VPC with the CIDR block 172.31.0.0/16, and the second VPC is having the CIDR block 10.55.0.0/16. Both are into different CIDR block ranges. Still we can create a VPC pairing connection, and once we create a VPC pairing connection and making some changes in the routing rules, we can connect the resources created in the VPC1 with the resources created in the VPC2. So what you can do in a real-time scenario is, let's say if your applications are running in this VPC and your databases are running in a separate VPC in a different region, you can connect them together, optimize them together with the help of the VPC pairing. How VPC pairing works? First we need to initiate a pairing request. So there has to be a source, or there has to be a requester VPC, and there has to be an acceptor VPC. The requester VPC is going to send a request to an acceptor VPC, acceptor VPC needs to accept the request, and that is mandatory. The request needs to be accepted within 7 days. Otherwise, afterwards, the pairing connectivity or the pairing request will be expired. If the acceptor VPC doesn't accept the request for the pairing connection, the pairing would not happen. The connectivity would not happen. Once the request is accepted, the pairing connection is created, and this pairing connection is a logical connectivity between the requester VPC and the acceptor VPC. After the pairing connection is created, it doesn't mean that the traffic is going to flow between the VPCs. No, we need to make some changes in the routing rules also. So we have to work on the route tables of each and every VPC. In the requester VPC route table, we need to send the traffic to the CIDR block of the acceptor VPC. So let's say this is a route table, for example. So here I need to add a rule which will point to the IP address of 10.55.0.0/16, and vice versa. I have to do it in the acceptor VPC also. So in this route table, I need to add a rule which will be pointed to the pairing connection, and the target is going to be the IP address of the requester VPC, which is 172.31.0.0/16. Rules needs to be implemented on both the route tables, otherwise the pairing connection or the traffic would not flow between the VPCs. And once these changes are done, then you can test it. What you can do is you can log in into one of the instances in the VPC, and from there you can jump into the instances in the other VPC also. If you are able to connect, if you are able to jump into the another VPC's instances, then the pairing connection is successful. So quite an interesting topic, quite an interesting functionality provided by the VPC, and with this you can create a lot of customized solutions as well. So region wise, if there are any restrictions, they can be overcome using the pairing connectivity option. So let's try to achieve this scenario also, and we will be covering up this demo in the labs as well. So the demo is connect two instances in different VPCs using a VPC pairing connection and then test the network connectivity. Now the next concept on the VPC, or you can say the next component of a VPC, is VPN and the direct connect. VPN stands for virtual private network. And guys, most of you must be knowing what exactly the virtual private network or the VPN is. VPN is a service that helps to connect your VPC to your data center through IP security or Internet Protocol security, which is a protocol. This is also called as an IPsec protocol. There is a tunnel with the help of this protocol that is created over the internet, and then using some credentials you can log in onto another's network with the help of a virtual private network or the VPN. So ideally what needs to happen is, when you create a VPN tunnels, make sure that you create 2 VPN tunnels for the production environment so that you can plan a redundancy and the failover. And where exactly you can use the VPN tunnel? You can use the VPN tunnel in connecting your on-prem data centers with the AWS resources. You can also use the VPN connectivity to connect the AWS resources with any other cloud platform, also with the customer network as well. So just like when you work from home, for example, and then when you connect from your home network to your office network with the help of a virtual private network connectivity using some credentials. So coming to the direct connect. The direct connect is a direct lease line from the AWS data center towards your corporate data center or to the on-prem environment. So a direct connect is a network service that provides a dedicated network connection from your premises to AWS without using an internet. It's a lease line. It is much more secure, much more faster as well, and it increases the bandwidth, reduces the cost, and provide a more consistent network. But it's a chargeable service. You have to apply for the direct connect line, and it takes around months or 2 months time to get that connectivity. The difference between the VPN and the direct connect is the VPN uses the internet bandwidth. Direct connect is a lease line connectivity. It's an optical fiber connectivity. VPN is suitable for small type of workloads like administrators connecting to the remote networks or resources. Direct connect is primarily best suited for connecting the data center equipments with the AWS services, as it reduces the latency, gives more bandwidth. VPN, on the other hand, is only related to the VPC. VPC is one of the service of an AWS. So let's say if I want to use VPN with the S3, it will not work. Whereas with the help of a direct connect, I can connect with any of the AWS services, which is outside the VPC also. That is one of the main difference between the VPN and the direct connect line. But the advantage of a VPN is it is set up very quickly. You just need to have a good internet connectivity and then you can set it up immediately. Whereas for the direct connect line, you need to wait for the connectivity. Thank you for watching this video, guys. Let's look into the demos on the VPC component.